Hello and welcome back. My name is Corey and you're my rubber ducks. And in this series, we are creating a programming language named Tang from scratch. And in the last episode, we did some heavy lifting. We added support for strings into our language. This time, I figured we would do something a little lighter weight. We have while loops in the language, and we have do while loops in the language, and I decided I want to add for loops. Now, there's a lot of different ways of creating for loops. There's the C style, and it exists in C++ and JavaScript as well, style for loops, and then there's something called a ranged for loop. And that might be something like Python, where for some variable in a collection, and it will iterate through that collection. And the question is which one are we going to do? And in short, we're going to do the C style for loops, but we will do the ranged for loops in at a later time. We have to have a little bit more stuff put together. I think that's the easiest way to say it. Have to have a little bit more structure before we can do that. Having said that, let's just jump in. And as I've said before, there's nothing up my sleeves, right? This is the 100% live coding, and you are seeing me from scratch. Excuse me. There we go. Hit the right combination of buttons to get it to show up. And if I say git log, you see that my last episode that I did was episode 29, and that was the previous one. So we're on episode 30. That's great. And git status, there's nothing else there. We know that we are about to, we're going to need, we're going to write for loops. So we need an AST node type to represent the for loops. Excuse me. So let's first make file. Let's just add the AST node 4. And where should we put that? I'm trying to keep these in alphabetical order. It's not always perfect, but it should go right here before the if else. And we'll just AST node 4. Sure. If else, we'll look for that. And now we're going to, I know, one of these days I'll learn how to make it do relative line numbers, but oh well. If else, and we're going to change that with 4. There we go. Okay, so now we need to actually make the AST nodes. So we're going to copy the include for the AST node, and let's do the while. I want to use the while. And we're going to call this include AST node 4.hpp. And we'll do the same thing with the source of AST node while. AST node 4.cpp. Okay, now we've got those two. What all are we going to need to open? I know that we're going to obviously need the include AST node while, the source for AST node while. We're also going to need the source program dump, the source program execute, flex, bison, and test. I think that's everything. Okay, so we're in the while that I opened the while, didn't I? Sorry, this was supposed to be the 4. I'm already making mistakes. There we go. It says while, but now we need to change this. So we're going to say %s and change the all caps while to an all caps 4 in the entire file. 3 lines, that is what I expected. And now we're also going to do it again. We're going to change the title case while to the title case 4 multiple times. There we go. And we're going to repeat that here. I didn't mean the buffer thing. There we go. Now let's make sure our comments match. So this is an AST node that represents an if statement. So we're going to have a condition. No, we're going to have a lot of things. We're going to have a we're definitely having the code block. But as for what we get, there we go. Okay, so let's change this. Instead of condition, we will say the init. This is the expression. To be executed first. The condition, whether the code block is executed, and then we've got the increment, the expression to be executed after each code block. Simple enough. So we've got the init, the initialization, the condition, and the increment. That's fine. Let's add this here. So we've got the initialization. Don't know why I'm having trouble with that word tonight. The condition and the increment. Of course, you may say, Corey, it doesn't have to increment. I know that. And we need, so the expression to be executed first to set up the for loop. Sure, why not? And that is the initialization. Condition is fine. This is not condition, this is increment, and this is the expression to be executed immediately after the code block. All of that looks good. And let's move on to the next one. So at the top, there we go. Initialization, condition, and increment. And now we need to do this. Initialization, condition, increment, code block. That's fine. And this is going to be for initialization, condition, increment, initialization, increment. That's fine. Code block. Now, what will the compile look like? Let's do the collect identifiers. Huh, that was easy. Okay, now let's look at the compile. So the condition start definitely needs to be there. For the start condition. There we go. But we need, there we go. Compile the initialization expression. And the fact that it is an expression is important, because when we say this initialization compile program, it's going to leave something on the stack, and that should be popped off. So we need to, we already have it here. There. Now, the condition start is going to be the correct thing. If the condition is false, jump to the end, that's fine. We know that we need the code block compile, and we've got to pop that. And then we need to compile the, what is it called? The increment expression. And again, it's an expression, so we need to add where's the pop? Right there. Okay. And everything else is the same. So we do the initialization. We only do it once. So we're going to, condition start's going to be the true start of the condition. Then we jump if false to the end, but we're reserving a space here, bytecode 0, because we don't know where that's going to be yet. Compile the code block, which has to have a pop at the end. We do that. We compile the expression, pop that. And last but not least, we jump to the, oh, well, we set we jump, and then we jump to the start and set the jump target of the condition false to the size +1. Why? Because there's going to be a pop. Okay, that actually sounds correct. Now at this moment, I'm going to go ahead and start the make test watch. It should compile without errors unless I made a typo. That happens. Tell us soon enough. Nope, no typos. That's always good. So let's, wrong window. There we go. And we've got our do whiles. Let's do an if. What should this look like? Now we haven't told Bison and Flex, so this is not going to work. But for now, let's it's going to be a control flow if Can I do this? I think so. The reason I want to is no, for. Why did I call this if up here? There we go. For A is, hey, we've got strings. So I'm going to say A is equal to the empty string for I is equal to 0, I is less than 10, I is equal to I plus 1, and we don't have a plus plus I or I plus plus. Again, if we want something to exist in the language, we have to write it, so we will we'll look at that. A is equal to A plus, and let's do a dash. And A. There we go. And that's an example of the raw strings, and I guess I'm kind of curious. When did they get that? Oh, C++11. Been there a while. Again, but it didn't exist when I started, so it's new. And what do we expect it to be equal to? We expect it to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm gonna add one more when we get there, but oh. Syntax error, I know. Stack is empty because it doesn't know how to handle the for loop. That's fine. What's funny is we don't have to. Yeah, we don't have to add anything to the program execute. And did I open those? I did. 3 and 4. We don't have to do that. Let's just go to Bison. We'll go to Bison first. Buffer 6. Okay. What do we need? We need the for identifier. Okay, so first of all, I already know that we're going to need this, so I'm just going to put it in here. And this is going to be a for expression. Okay? You don't know what it's for yet. I'm just going to say we're going to need it. Well, I'll go ahead and tell you. We've got a for open parentheses, a for expression, semicolon, a for expression. Say, Corey, isn't that just an expression? Almost. It almost is. I'll show you. So, for expression, and now, oh, up here, we've got our while, our as, that was for casting. So let's just do something here. For and for. All right, gonna go back to the, this is now flex. And we need to Oh, there it is. While, instead of a while, we need to add a for. Keep doing that. Okay, it should compile. Still won't be working correctly, but we will, let's define it. First, we need that's fine. I'm sorry. I just kind of stopped talking because I was thinking. We've got our do statement here. So for is going to need this, and it's going to need a for expression, which we haven't defined yet, but we're about to. A semicolon, another for expression, a semicolon, and another for expression. Followed by a close there. And now a closed statement. Yep. And that's the 4 parts that we need. So is equal to standard make shared an AST node 4, and we're going to pass it in the 1, 2, 3. $3 is the first for expression, then $5, and then $3, 5, 7, and then the 9. Okay, now what is a for expression? Oh, by the way, we're going to need the same thing down here, but with, or by, under the open statement. But instead of it being a close statement at the end, it needs to be an open statement. And again, for expression is used but not defined. We need to define for expressions. And we can just put it right here, in fact. That's where I want it to do. Okay. Meant to hit that button. Is an optional expression, which means it could exist or it could be empty. All right. The problem is well, if it's empty, well, let's just go from there. For expression, it could be, and here's a new one, empty, and I would want to make sure that there's not anything else I need to put there. So double check my notes. Nope. And what happens if we run across this? Well, we say the $sign is equal to, and it's a shared pointer to an AST node. And I think I'm going to do this as a standard make shared. Yeah, I'll do it that way. Standard make shared AST node. Why? Because that will actually just push a null. That's what I'm going to do. Otherwise, we've got this, and just making sure I didn't do anything else weird, expression, but we're just going to pass it through. So if I don't do anything, it's just going to pass that for expression through. And now it's probably complaining that it doesn't know what an AST node is. I could be wrong. Oh, AST node 4, of course. AST node 4. Bison didn't give me any errors. Oh, I need to give it a location. That's fine. On the empty thing right here, I need to say that one. I think that will work. No, so it doesn't exist. Nothing is there. How can I say an empty location? Looking to see if I've got a note on that. I'm not seeing it, but what I think we can do is say a Tang location. Can I just initialize an empty location? Does it know what a location is? Probably not. No matching function for call construct. Do I have location included? It is being included. Okay, that's good. Tang location. And in every case, I've been feeding it a location. So, in this case, do I have... No, I don't have this open. So, WSL view, not include docs, HTML index. There we go. Our classes, we should have the location class. And it's a constructor. We've got these. And I'm wondering if the... This position, it has a default. So, I haven't done anything. It should error out on me. Oh, and of course the this one needs the location, so we'll say at 1. And it's still not liking the first of all, which one is it erroring on? Let's do that one first. So there it says 271. Which is this here. Oh, of course. At 1. Oh, so it did accept the location with the NP constructor. There we go. 3, 4, 5, 6, 7, 8, 9, 10. And I only gave it 9. So, which one is this? The test. If I now do this, whoops. There. When you click on when you do something, it enacts the scroll lock, so it can't scroll. So you had to hit Control Q, and that's what had happened. So I hit not Control Q. Oh no, wait. Yes, Control Q. I said it right. All right. Let's do another one. That is, so there's 7. And this is also, this is going to be program 2. And the only difference, well, first of all, I'm going to, so that you can't say, here, let's just say 3. There should only be 3 of them. But, is it working with the open statement? Should get an error. And it did only do 3. Good. All right. Now, I am curious. I want to see, let's do this one up here. We're going to do cout p1 dot dump bytecode. There we go. And let's see what all this produces. So first of all, this is our A and I. It's got to be A then I. Okay, so we get a string of nothing. We poke that into memory stack position 0 and pop it because the poke doesn't pop. Integer 0, poke that into I and pop it. We now load this this peak and integer 10, and then less than jump if false to 39, which is loading the A. That's fine. If it's true, peak 0, which is load the A, do the string as a single minus, add that, poke a 0. Oh, yeah, store that in A. So we've added it and stored in A and pop it. Peak 1, that is I, we're going to be to this part. Integer 1, add them together, poke that back in I, and pop it. And now jump to 12. And 12 is going to be the load one. Now, this is a good example where the optimization won't work for the poke, pop, peek. Because if I'm jumping to 1, I can't... What we were saying earlier is by saying poke, then pop, then peek, if we just got rid of the pop and peek, it would poke it into stack position 1, and it doesn't have to reload it. But at this point, if you're jumping to 12, it can't be removed. So I want to edit my... This is include Tang. And make sure after a jump, when poke and peek are the same, and I say if not a jump target. And I'm going to even add (27) is often a jump target when (26) is from a 4 initialization. Yeah, that's easy enough. And that's just so that I have that information. Okay. Okay, so that took 39 is the last number. And now we're going to replace that with 2. We'll dump its bytecode and see where we are there. Also 39. That's fine. That's pretty much what we expected, right? It's the exact same statements. What about... Let's do a few others. And I'm going to say... Ooh, I do need this to have that. And we'll say, oh, here, I is equal to 0. Now, you say, Corey, in theory, isn't it the same? It should be. That's actually what we're testing. The reason I say that is it's not exactly, because these are going to generate an op null that gets popped off. And in fact, I should have... The test passed. I want to print it out. P3. All right, and as you see, the other one was only 39. This one goes up to 43. Why? Because, get this here, we're going to have our poke the value 0 into, that's the I, pop that off, and now here, null value, and then pop, and then now we're into the condition, jump if false, with a pop, and now peak 0, that's going into the A. We go all the way down to the, let's see, integer 1, add, poke that into I, pop it, and now look, this is the post increment, null val. And then there's the pop, and then the jump to 14. Where is this? Jump to 14, which is peak 1. Yeah, so we've got a few extra steps. Even though we would look at it and say it's the same, the compiler adds a few extra opcodes. However, a null value followed immediately by a pop should be able to be optimized out as long as neither one of them is the target. As long as 13 is not the target. 12 could be the target of a jump because, yeah, it would just load a null and then exit out. But, okay. Another optimization might be, because this is going to create a string every single time, meaning a string literal, and maybe we want that to only happen once because that takes a little bit of extra work. It's only create the string literal once and load the string literal from a stack location each time. We might do that. We'll think about it. But that can be a little later. So for this, it works. Now the question is, do we need to do any more tests? You say this feels a little light, but oh yeah, we could test to see if it if we do nothing, right? So let's and what we're going to do, it is I is greater than 10. And let's do this as remove it. And this should have the value of null. Oh, it's not a P1 though. We're up to P4. And it passes. Yeah. Okay. At this point I don't think we need to do it. We could. This could be our P5, and instead, there. Should still be a null pointer. It's just the open versus closed. And what if we want to try a double loop? This will be 6. And we'll say that will J So what are we doing? This is should be less than. Oops, I did something there. And this is going to A is equal to 0, and I will say A is equal to A plus 1. And what should it be? It should actually be 100. Just writing it as 10 for the moment, but it should be 100. Yeah, it says it should be 100 and it's only 10, so we just And you may get tired of seeing this, but to me there's something, no, it should be dump bytecode. There's something beautiful about seeing how it gets compiled. And it's 62, okay. But we've got our A, our I, and our J. And yeah, there's our jump if false pop for the I, jump if false pop for the J. And it works. We could, I mean, in optimizations, right, there's going to be like this pop would be optimized out and stuff like that because it's never executed, but it's actually impossible to execute it. But that's not the point. The point is a double loop works. All right, and let's see what our differences are. Do they make sense? They do. We're going to commit this. All right. I don't know if you can hear it, but that's my fan on my computer sounding like a 747 taking off. And now reload this, and we've somewhere in here we've got an AST node 4. Yes. And that what episode are we on? I know I looked at this just a moment ago, but I've been thinking really hard since then. Episode 30. Yes, episode 30. Say, Corey, do you think we'll get into the triple digits at this point? Maybe. Again, I know how much work it's gonna take to get to get functions working, to get objects working, arrays. What else? Oh yeah, our ranged for, indexing. It's maybe not, but it's a lot. And lastly, make clock. Just kind of seeing where we are. It's a decent number. The number of lines reported by GitHub are vastly inflated because I'm pushing documentation that's automatically generated, and a lot of those files are MD5 sums of things that change. And so that's how, what's the name of the tool? Doxygen can redo the documentation very quickly. I actually just delete it all and have it generated again. But you don't have to do that. You could. The only reason I do it is so that when I remove files, or if it wouldn't have generated a file, then it no longer should be in the repository, and I can remove it that way. But generally speaking, no, you don't need to delete the docs directory. And I know that. I knew it before I even started this project, but I just do it to try to maintain a clean docs directory. Yes. So, all right. Having said that, I think we are at a stopping point, and I'm curious. I think we're around the hour point. We are very much less than an hour, and I'm not going to keep you any longer. So once again, thank you for joining me. We have for loops in our language, and yeah. As always, have a great day.